Hello folks, my name is Fernando Teixeira and I'm a senior instructor at AWS, currently teaching at the AWS Cloud Institute. Today, let's take a look at the practical steps for adding Gen AI to an application. I'm going to be using Amazon Bedrock to select a model, and then I'll write the code to invoke that model in Bedrock using a Lambda function. By the way, today my background, I have the Italian Alps. And no, I didn't use AI to create that picture. I actually had to do it the hard way and hike up there myself. So let's start by looking at my prerequisites, and that shouldn't be much of a problem. I'm going to need an AWS account, I'm going to need some programming credentials, I'm going to need the AWS SDK for Python because that's the language we're going to be using in this example, and I'm going to need a basic understanding of Lambda. But the good news is I have videos for all of those, and I'm going to include those in the description below. Now this session builds on the simple sample application I've been building where you can keep track of your trips over here in a database, in a DynamoDB database. But more important for this session, you can specify some trip interests and some additional guidelines for your trip. And then we're going to use AI to generate a complete hour by hour, activity by activity itinerary. Now, I don't want to walk through a whole demo of this, but I do have a separate video that I'm going to include in the description where you can actually see a live demo of this running application. This is a quick look at the application architecture where I have a React front end using API gateway APIs to invoke Lambda functions that implement the backend functionality. But our focus today is strictly going to be on that trip itinerary Lambda function invoking the Bedrock model. But if you want to look a little more on the application architecture, yep, I have yet another video that talks just about the overall architecture picture, and I'm going to include that link as well. Let's get started with Amazon Bedrock. Bedrock is basically one-stop shopping for foundation models. You get hundreds of models in one place, from industry leaders to some emerging providers. Now, I'm not going to show everything that you're going to see in Bedrock. There's like new stuff coming up all the time, so I'm going to leave that to the Bedrock team. As it is with the rest of my series, my focus here is in the development aspect, so I'm going to use Bedrock to play around a little bit coming up. I'm going to select the model I want, and then we're going to jump into Lambda to show some code that is actually going to invoke that model using the Bedrock API. To pick my model, I'm going to start over here at the model catalog. And you can see there are a ton of models available over here by a number of different providers. It's not just those. I can keep clicking show 10 more, show 10 more, and more of them are going to come up. The models will change by region. North Virginia, US East 1 tends to be the one that has the most now, but yeah, all the regions are going to have a bunch. You can also pick different modalities over here. Of course, there's a lot of text models, which I'm going to need, but there's a number of image models, all audio models. I'm going to select a model for Amazon, well, because I do work for Amazon. So I'm going to go over here and let's see, out of the Amazon ones, let's pick the Amazon Nova Pro. Let's take a look at it. Let me close this thing on the left side to give me a little more real estate. One thing that is important, if I go over here to the bottom on the usage, this is important documentation I'm going to need, because if I click this over here, that's going to open AWS documentation. Yeah, that's the stuff that I'm going to use to be able to write my code later. Well, in addition to using a little bit of a AI to help me with that. Going back over here, if I scroll back up, I mean, there's a lot of information over here, right? But I'm going to go straight to open in the playground, because that's a wonderful feature that's going to allow me to test my model and just play around with it, a few different models to see which one I want to use. Okay, now we're here on the playground. I'm going to expand my settings over here so I can see the various things that I can change. Now, I know I'm going to be generating a lot of text for my itinerary, so I'm going to start by increasing the number of tokens. I'm going to max them out that I'm going to need. You do pay for the amount of output you generate, but yeah, it's just for a test of here, so no big deal. I'm going to take a trip that I have saved on a separate text file over here and drop it here so we can see the trip. So for this trip, I'm going to have a trip that starts in July and also in July, well, 9 days to Scotland. Now I picked that because I actually did use AI to generate a trip to Scotland this past year. I never ended up going for various reasons, but it's the kind of stuff that I wanted. Some hiking, rivers, lakes, waterfalls. I'm a nature guy, and of course always some good food. Little bit of extra guidelines because I only want at most 2 activities per day. Of course, not counting meals because, I do need to eat. So with all that said, let me go over here and run this. All right, I start generating. Let me just kind of scroll down as it is generating. Okay. Yeah, I can start looking at this going. Oh, pretty cool. Yeah, it has me arriving at Edinburgh, hiking, Loch Lomond, the Tresons, Fort Williams, Ben Nevis, Hotel. Okay. Oh yeah, that was important. I was looking for this one because if the trip didn't give me the Isle of Skye, that's the one place in Scotland I really want to go. It looks so pretty. And it did give us, so we passed that test. All right, that looks pretty cool. That looks pretty detailed. So I like this. But perhaps there's a better one out there. So we can test that out. I can go over here and I can click on compare mode. And that's going to allow me to actually test out side by side two models. Now I already have the Nova over here on the left side. On the right side though, I'm going to pick a different one. Let's try Anthropic Cloud Sonnet 4.5 and apply. And now I can take that same trip that I picked before and I can see what both of those are going to generate side by side. So let me run. All right, now they're all done. I can scroll real quick. Yeah. Oh, it's funny. It's slightly different. Is it a different format? Yeah, anytime with generative AI, you can get something slightly different. So it's slightly different format on the Nova side. I can even check. Was it really the Nova? Yep, there was a Nova Pro over here. Good. Let's take a look at the Cloud Sonnet. So if I start scrolling down over here, it's funny. The Cloud Sonnet now looks a little closer to what my initial Nova Pro was. Okay, I'm going to do my... yeah, it did do the Isle of Skye on the 4th day. Slightly different itinerary. No, but it also looks cool. Yeah. I like this. This one gives me some notes and tips. Well, that's pretty good. So now I have my two models. Now I can get ready to implement. And I'm going to go with the Nova Pro because, it is an Amazon model. But this is where the documentation I showed earlier is going to be very important because that's where I'm going to get the details of the API that I'm going to need to invoke from Lambda. We're moving on to Lambda, but once again, I'm not going to be giving you all the details about Lambda because I have another video for that and I'm going to put that in the description. So we're going to be looking at the coding for Bedrock instead and some of the extra testing and permissions and things like that. So here we are at the trip itinerary Lambda function, and that's the function that is going to generate the itinerary based on the customer's input. Now, I know everybody is eager to jump into code, but the code won't be able to do anything unless I have the right permissions. So I'm going to go over here to configurations and permissions, and I'm going to open the IAM role I've created to have the permissions to invoke Bedrock. Now my IAM role over here is pretty standard. I have the IAM Lambda basic execution role, AWS managed policy that pretty much every Lambda function has, and I added this one over here, Amazon Bedrock full access. Now, if you look at this and go, well, full access seems a little bit too much if you're just invoking the function, and you would be right. However, I didn't find any existing AWS managed policy for just invoking a Bedrock API, so I used the full access. If this was a production application where I do want to apply that minimal set of permissions, I would create a custom one and just add those policies that I needed. Now, back over here in the Lambda function, we can finally look at the code, but it looks a little crowded here, so I'm going to use this great new feature where I can open my code in Visual Studio Code. There is this set of README instructions over here, but we're not going to need that. We're just going to jump over here and start walking through the code. Now, I'm using Python here, and that's consistent with the other videos I've done in this series, but when it comes to AWS interactions, this would really be the same for any programming language. You just need to update the syntax. Now, if you look at my code, yes, I have a bit of stuff here on preparing a request and parsing the response. But really, when it comes down to the AWS calls, I use the same 3 steps I use for any service. I need to include the SDK, that's Bodo for Python. Then I need to create a client object over here. So I'm creating the Bedrock client over here since I'm using Bedrock. And then all the way down on the bottom over here, after all my preparation, I'm going to eventually use that client over here, that Bedrock client object, to invoke my model. So whether it's Java, C++, C#, you're always going to follow those same 3 steps. Right, so let's start looking at the code over here, and we'll start at the top at the beginning of my Lambda handler. I like looking at my handler first because that essentially gives me the outline of my entire function, particularly if you do it well. Remember, the handler is like the main on a Java program, so I don't want to stuff everything on my handler. I just want to have the quick outline and then call specific functions. So let's take a look at it. I have a lot of logger statements in there. I'm not going to break that down. That's just me putting a lot of logs. That's always good for Lambda since a lot of the stuff happens in the background. Then I'm going to have to get my request payload. Now I have to go back and remember the API gateway is what's calling my Lambda function. That was part of that architecture that I showed. So I know what the payload looks like on an API gateway request. And I know that I'm going to get my request out of the event body. So event body is going to give me my request. Now that I have my request, well, I take specific things out of the request. I've designed, of course, a JSON for this particular application. And I know that I want to get the things that are critical from my customer input. The start date, the start time of the trip, the end date, the end time, the location of the trip. And then if you recall, either the demo that I showed or even the screenshot I had, I have two little input fields for customizing my itinerary, and that's just overall interest and some guidelines for extra guardrails that my customer might want to put. So once I have all of those, I'm going to prepare the request that I'm going to need to use for Bedrock. I have a separate method for that. I'll discuss that method later. Then I make that Bedrock call. That's going to give me a response. Then after I get my response, I'm going to have to parse it. I actually get a CSV back out of my request. I'm going to explain that why when I talk about how I design my prompt. After I get the CSV, I will convert that to a JSON response because going back to the API, I am going to want JSON that's consistent with most of my Lambda functions. I take in JSON, I reply with JSON. So that's the full picture. Now let's start breaking things down one by one. Before I get to the specific functions, I'm going to start over here with my actual call to the Bedrock Invoke Model API. Let's take a look at the parameters. I have this very important one here, model ID. I should point out that the parameters for this call can change a little bit depending on which model I'm using, but that's just a matter of looking up documentation. But this model ID is important because it specifies the model that I'm using. So obviously you can tell this is a variable. If I scroll all the way up to the top of my code, I get over here to the model ID, and yes, I like to get that out of the environment. Good programming practice, easier to change. So I have an environment variable for this model ID. But where do I get that value? Well, one would think, myself included, that the answer would be as simple as going over here to our model catalog. Remember, we were there earlier. And for the Nova Pro, which is the model I'm using, if I scroll down over here, I have this Amazon Nova Pro. That's the idea. I'm going to copy this. I'm going to put it in the environment variable, right? Not quite, because I tried this and I got an error. For some models, they actually require you to use something called an inference profile. And the inference profile is down here. If I click on cross-region inference, let me close this up a little bit. Now, that gets a little deeper than I want to get for this kind of a session, but it's essentially a way that you can customize a little bit your call into what regions it's going to go, perhaps have calls going to a couple of different regions. So it can get a little complicated if you're very picky about it, but nice thing is AWS does give you some system-defined inference profiles. So I just need to scroll down here and look for the Nova Pro. Yeah, there you go. And when I look here, I can see that I do have this one predefined by AWS that I can use. So this one, if I copy this one, now I can go to my Lambda function over here in the configuration and the environment variables. Yeah, you can see I have the environment variable model ID set to that value that was in the other screen, the US Amazon Nova Pro 1.0. So that's how I set my model ID. While I'm in the screen, I might as well show you that the prompt I'm going to use for my call is down here in this prompt template variable. Yeah, it's a little hard to read over here, but don't worry, we're not going to look at it over here in this one stretched outline. I'm going to show you in a nicer format. Yeah, so this prompt environment variable over here, prompt template, is going to be set into this variable, and that's the variable that I'm going to use when I look at the building of my request, which you're going to see next. Okay, so I'm going to scroll down here to our prepare request function, and prepare request takes in all of the input data that came from the user's request. We saw in our Lambda handle before how we got that out of the request body. Then I'm going to take that prompt template, the one that I read from the environment, and I'm going to fill in with the values that the user passed. Now, the format of the prompt template, I kind of have it over here in this file. Of course, this is not what the code is using. The code is using the environment variable, but for visibility, yeah, this is exactly the string that I built, and then I just paste it into the environment variable in Lambda, but it's a lot easier to see, and frankly, for me to even construct this on a flat file like that. So all of those open braces and close braces, yeah, that's how you do a formatted string in Python. Every language has a different way, but the way it works in Python is if you have a string like this with those open and close braces right there, and you use the format call, that's gonna fill in that the open, close, and close braces with all the values that get passed in. So note that the end result is that this prompt variable is going to have a structure like this, a string like this, but where we have the braces, going to have the actual start date, the actual trip location, the actual trip interest, so that I can then use that for my prompt. Right, so back here at my code, I will look at the full prompt engineering side of this in a little bit, but first I want to get to the mechanics of the call. I use this particular format for my request payload. Yes, I looked up documentation, or I use AI. There's a number of ways that you can get the simple format. That prompt that I built over here is gonna go right down here, the role of user, since the user is the one that is actually, playing that persona right now with that prompt. I then have a couple of different variables that are using my inference. You can look at a lot of documentation on all the different ways you can influence a certain type of model. In this case, max tokens, I opted out from the default one because, as I talked about in the very beginning when I was in the playground, that's where the playground is great. I do need more than the default because I expect to have a relatively big response. Temperature is essentially how random you want your answer to be. Very high temperature makes your request kind of go in a lot of different places. If you want a very boring, you always get the same thing, you make it pretty low. Top P is how wide you look for different answers. The higher the top P, the more options the model is going to look at. A smaller top P is only going to look at the very few things that are considered the most likely ones. You can always tweak those. The playground is a place so you can play with that, as I showed you earlier. So right here, I will be completely building that request, and that request, remember, that gets sent back over here down to my Lambda handler. Yeah, that request over here, request payload, is what I'm gonna pass when I invoke my model. Okay, now as promised, here's a little bit of discussion on prompt engineering, and there are a million places out there talking about prompt engineering. I recommend you look at all the good tips out there. Those are just some of mine as I was working on this. At a high level, you can see that I separate multiple sections over here with what's called XML style pieces for my user input, my response logic. So I have an open one and a closed one, my response format, open one and close one, and then finally some guardrails. Yes, that's a good recommendation I've seen in a few different places. Not only does the model appreciate that, you can appreciate that as you're trying to make sense of the things you want to put there. Honestly, it even helps you think. The extra end of line over here at the end of every line, also recommendation. Some models actually expect that to have that end of line. Again, all of that stuff could change in the future, but from what I saw, that was an important thing for many of them. Right, so let me take a look at my individual pieces over here. My user input is an easy one. I already said I am just filling in what are the things that are gonna come in from the user. That's easy peasy. Then I get to my response logic. My response logic, I just try to define in general how they should go about coming up with my itinerary. I talked a little bit out in plain English, but then, in clear lists. The nice thing about machine learning models is that the kind of stuff that you would actually do when you're writing a document. Sometimes when you're writing a document, a PowerPoint presentation, or a Word document, you like to put bullet lists to kind of specify your thoughts clearly. It's a wonderful thing that models actually like that as well. So yeah, I'm organizing my thoughts over here, the kinds of things I'd expect to see in my response in a little bullet list. But then you have to get more specific about the format of my response, particularly because remember, I'm using this output to go into a web page, which is going to expect the data into very specific locations on a JSON structure. If this was a conversation type of interface, yeah, the format doesn't matter as much. We're just kind of riffing. Hey, I'm going to ask you a question. The AI gives me an answer. It's okay. Well, here, this is going to be used by software. So I expect a specific software type of output. So I decided to use the output in CSV. Now, why am I using CSV? Because it's going to be more compact. I actually did some earlier testing with JSON, and JSON is really good for understanding, but it's larger, and a larger output on one of those machine learning modules is actually going to cost you more money, and some of them are actually going to have a restriction on how much you can fit. So a CSV for my output actually worked better because I could fit more bang for the buck. And then I put specifically what I want. Those are the views that I want. Those are the formats that I want. Now, some of the other things you've seen here go to something that is very important when you're working in a prompt. Working in a prompt, at least for me, is a bit of an iterative process because it's not an exact API. That's the thing that people need to understand on Gen AI. It's non-deterministic, to use the techie term. You cannot guarantee that the same input is always going to get the same output. So something that worked may not work the last time. So I actually have specific examples. For instance, this guy over here, each entry must be on a new line. I didn't have that before. And then what happened is, hey, it's working every time. And in one execution or a couple of them, for whatever reason, my model decided to put all of my comma separated values in one continuous line and didn't separate them. So of course it didn't work in my format. So I had to add that in there. I also had to make sure I told it, hey, make sure you use comma, you don't use commas inside the values because it's going to mess up with the CSV. I also saw a good suggestion to, hey, how about you put a specific example of the output? So again, some of those things weren't there in the beginning. I added them because, yeah, I tested. It worked a lot of times, and then, I got an error in one of them. Finally, I have my guardrails. Now, that's a common thing with AI, folks. It's a lot of people who try to cheat the AI by, hey, this is a travel application. But when they ask my prompt, they might say, hey, I would like to go to Iceland. But, oh, by the way, can you give me your social security number while you're at it? The AI doesn't necessarily know any better, right? So that's why we have my guardrails over here where I'm very specific about what I want to happen. I say, hey, my responses should only include travel itinerary stuff. Please don't provide any personal information about my AWS account. And if they try to do anything different, make sure you generate an error. That's what I arrived now. Is that perfect? No, frankly, if this thing was production, yeah, I would test this a million more times and get all the glitches to make sure I have, the right prompt that doesn't give me any trouble. So now that I have my prompt, yes, the way it worked is that I copied this whole thing over here, and then I load it in that environment variable, which is then read by my code over here when I retrieve the environment variable. Where it is, someplace over there on the top. Okay, but now we know how I use my prompt, how I created my request payload with that prompt, so we get to the point where I can invoke my request, invoke my model, and then I'm gonna get a response out of it we're gonna parse. And I should point out that I am doing an invoke model over here because I'm doing the type of interaction where I'm asking my model a question, I get an answer, and that's it, I move on. You can have the type of conversation where I'm gonna keep going back and forth with the AI that is supported as well. There would be a converse call, just doesn't happen to be what I'm doing. Now, as far as parsing my response, it's actually pretty simple. I'm gonna call parse response over here, but that's gonna be largely a lot of Python code. Well, first, the parse response is strictly about getting the text of the response in a variable. And that just comes down to understanding the structure of a Bedrock response, which I get out of documentation or I get out of asking AI. Now, that text, which gets returned back, is actually the text of the CSV format that I requested. So response CSV, yeah, that's that CSV format that I asked for in my prompt. I'm going to convert that to JSON on the CSV itinerary to JSON. That is going to be straight out Python coding. So if I go over here, I'll go quickly for why I have certain things, but again, I'll share the code. You can look more carefully. By experimentation, I found out, for instance, that sometimes I got a reply that included this marker CSV, and they're complicated. Again, a lot of it is trial and error. Told you Gen AI is not deterministic. So I just wrote a little bit of pattern matching code in Python, Java, every language has something that basically strips that extra little header if it's in there. So after I get a pure CSV text, I use again Python code to read that line by line. I eliminate I don't want my header row included, and then I'm just gonna build a structure. In the end, I'm gonna have a list, a JSON list of different items like this that are gonna have each one of them one specific activity in my itinerary. You will see the output when I run the demo, but I think it's pretty self-explanatory over here. And that's the JSON that I'm going to return. And as I mentioned earlier, that JSON gets responded to my customer. So now let's go back to Lambda so you can run some tests. Back in our Lambda function, I should point out that had we made any changes in the code, I could have deployed it straight from VS Code, but I didn't, so I can jump straight to the test feature. If you're interested in the test feature or anything else in Lambda, I do have a separate video I recorded just for that. I'm going to include the link in the description. So I have this Vermont trip itinerary here. I use the standard Lambda testing feature API gateway template. But remember, we actually wanted that body. There's all this stuff, but body was where we knew that our request, the input from the user was coming. So I can see the body now. It's a little hard to see here because everything is escaped. If I scroll, you can see, yeah, it's a trip to Vermont, nature, hikes, and waterfalls. A little hard to read here because I have to escape it as a string, but to make life a little easier, I did put it, the equivalent version right here on the notepad. So you can see it's a simple trip to Vermont in October. Just 3 days. Vermont is not too far from me. Nature, hikes, waterfalls, 2 activities per day. Shorter than 5 miles because I don't want to kill myself. So I'm going to go over here and yeah, using the Lambda feature, we're going to test this out. So let's go over here to the top and click test. Now with Lambda, the results are going to come right here. Yep, I can see a little summary. So if I stretch that out, yeah, I can see, enjoy a delicious dinner. So it looks like it worked. But once again, the JSON output with the string escaped, a little harder to read. So I'm going to take this and I'm going to put it in a separate file in a second for you. I promise you this is exactly what I had over there in the response of the call to Lambda, but I kind of have it nicer over here so you can read it. So let's see, enjoy a delicious dinner. Yeah, then yeah, food is good. Let's look at my hikes. The Camel's Hump State Park. Explore the stunning Bond Falls. Just, and I like to always make sure I'm not cheating you. If you go back to the Lambda function here, you should be able to see those over here. Yeah, the Camel's Hump State Park. So it seemed like it worked, but there's one more way I want to show you the output so you can really see it in action. Now, I know I'm cheating ahead a little bit, but I had to see this in the UI. So my cat Finn over here is taking a trip to Rio de Janeiro for about a week in January. So let's create an itinerary for him. So let's see, Finn is interested on, he's going to Rio, so he has to be beaches, but there are some nice historical sites in Rio as well. Yeah, let's keep it simple. Additional trip guidelines. Let's keep them to only 2 activities per day, plus meals. Oh, and of course, almost forgot, good food over here on the trip interest. And let's generate that itinerary. So here we are at the trip. And let's see, it looks pretty good. I have the Corcovado Mountain, it's very pretty. Copacabana Beach. Some dining places. Garota de Ipanema, for those who know the song Girl from Ipanema, that's actually where the creators were inspired by looking at the Girl from Ipanema while you're sitting at that bar. All right. Yeah, it's a nice little balance over here of everything. So I think I like it. If you're interested on the UI and the APIs that we use on the UI, that's coming up. I promise you I have videos that I'm going to be producing for those. But that's it for the AI today. So thank you for being here. Remember, my goal was not to give you a complete guide of implementing generative AI or how to use a specific model. At the speed that things are moving, chances are the exact steps I use are going to be changed by the time you watch this. The point is to show you that it doesn't have to be that hard. With the AWS SDK, invoking a model in Bedrock is really no harder than making a database call in DynamoDB. So look in my description for my other videos and the location of the code I'm sharing. And as the viral influencers like to say, click like and subscribe.